Hi everybody, welcome to another video in Math 1324, section 5.2, system of linear inequality into variables. So this is just similar to previous section, but this time we will have two instead of one. So the system of linear inequality is what we do with now. We will find all the points satisfy all the inequality in the system, and these points are in the solution region or the fishbowl region, and the solution will be the intersection of all the graph of the inequality in the system. So pretty much it satisfies every inequality in the system, and that will be the intersection of all of the regions. And then we have the corner, which is intersection of boundaries. And if the solution can be enclosed by a circle, doesn't matter how big the circle is, it is said to be bounded, otherwise it is unbounded. And we do have some example like that. Right. Other than that, we're just going to graph two inequalities, a system inequality, and then find the intersection. Or sometimes we have more than two. Right, so first let's graph this x plus 2y. Now we have, when we graph it, I'm just going to make it equal to, and so it's easier to graph. Graph a line first, and then we graph, then we test point. So if we choose x to be 0, then we don't have x anymore. We have 2y equal to 6. 2y equal to 6, so y is equal to 3. Right? If we choose y to be 0, then we just have x equal to 6. So we have those 2 points. We're going to graph that later. Now just go to the next one. 2x minus y equal to 0. When x equal to 0, then negative y equal to 0, so y equal to 0. So obviously we have the point 0, 0 here. So we have to do something else for x, something y for y. I'll choose, let's say, do something else for x. Let's say when x equal to 2, yep, 2 times 2 minus y equal to 0. So that 4 equal to y. So x equal to 2, y equal to 4. Right, so we have the points. Now let's plot them. First, 0 and 3, 6 and 0. This one has the equal sign in the inequality, so it is a solid line. So once again, it has equal sign, so it's a solid line. I just have to pause the video and change the ink for the blue pen. Now for this one, okay, test one. We don't have the point 0, 0 here, so we can test 0, 0. Put 0 for x and 0 for y, and we test if it is true or not. And we have 0 greater than or equal to 6, which is false. So that's why 0, 0 is not part of the solution. 0, 0 is here, and it's false. So we have to go across the line, and we will say that region. We'll go to the second one. We will test, of course we cannot test 0, 0, or we haven't graphed it yet. So 0, 0, and x equal to 2, y equal to 4. And this one has no equal sign, so it has to be a dash line. So that is that line. Now with test, we can choose anything. Let's choose this point, x equal to 2, x equal to 0, y equal to 2, right? Put 0 for x and 2 for y, because we can just take any point not on a line to test. And is it true? So that -2 less than 0, so that is true. So we will set the region that contained in this point. So we go like this. And put both of them together. We have this overlapping regions. Of course, we still need to find this intersection as well. So for that, I'm just going to use the calculator. Just show the system of equation using the calculator. Okay, second matrix. Alpha zoom. One, 2, and 6. 2, 2, -1, and 0. I should have 1.2. and 2.4. X equal to 1.2, y equal to 2.4. Right, so that is the answer. That region along with the point. Right. Next we're going to graph this. Well, this have plenty of inequality, but if we focus on the x greater than equal to 0, y greater than equal to 0, we only need to graph in this part of the graph. We don't need to go to the left of the y-axis or below the x-axis, just in that corner, that quadrant 1. Right. So take care of that. Just going to graph in here. Next we have x less than equal to 15. We're going to graph that. 2. So x less than equal to 15. And that's just a vertical line. But we have to see where the 15 is. So I'm going to graph that in a bit later. Now just graph the other inequality first. Right. So first I'm going to make it equal to. And we graph the line first and then we test with the inequality. Right. X and y. If we choose x to be 0, then we don't have x, a, y equal to 160. So divide by 8 on both sides, we have y equal to 20. Now when we let y equal to 0, we have ax equal to 160. Again, divide by 8 on both sides, we have 20. So the point is 20, 0, and 0, 20. Now let's test here too. So 0, 0, 0 and 0 I put in this inequality. Not sure if this is true. So that gives us 0 less than equal to 160, and that is true because 0 is less than 160. So yeah, keep that in the back pocket. We'll graph that later. There's a reason we don't want to graph right after we get this information. See why in a minute. Now we want to graph this one. Ax plus 12y equal to 180. We just make it equal to. When x equal to 0, we have 12y equal to 180. We take 180 divided by 12. That would be 15. At 15. And then now we choose y to be equal to 0. Then 180 divided by 8. I don't know why I tried 8. Sorry. Yeah, that's much better. 180 divided by 4. That's 45. So we have that. And then we do the test point. We put 0 and 0 here. So that is 0 less than equal to 180. So that is true. Right. And then we have 15, because if we want to graph, we can choose whatever y is, but x have to be equal to 15. That's easy. Right. Let's choose 0 and 20. Right. Now, the reason that we need all of this point before we graph, so we know that x, on the x value 0, 20, 15, and 45. So we have to choose x to be big enough to have up to at least 45. And y have to be big as 20. Right. So in that case, we have 10 ticks here on the horizontal, 10 on the top. So if we choose 5 each, that would be good. So 0 and 20, 20 and 0. Again, x greater than equal to 0, y greater than equal to 0. We will not need to draw anything past the y-axis or the x-axis. Just stay at the upper right-hand corner here. And on this one, we have true. So the point 0, 0 belongs to the region 0, 0 below the x-axis. I mean below the line. So we're going to say it below it. Right. Next, 0 and 15, 45 and 0. and the point 0, 0 belongs to the region. It is below the line, so we will set below it. We also set I have the line, the vertical line at 15, and it has the equal sign, so we have the solid line. X equal to 15, y equal to 0, 15 and 20. So yeah, and now we test if x equal to 0, it will be true, so it will be on the left side here. To put all of that together, we have this region. Right. Now we do need to find the intersection here and here. Now this intersection is easy because we know that belongs to the vertical line of x equal to 15, and it is intersection with this equation. So we have put 15 in that, 8 times 15 plus ay equal to 160. So a times 15 is 120. Subtract 120 on both sides. Ay is equal to 40. 160 minus 120 is 40. And now divide by 8 on both sides, we have 5. So we have the point here is 5 and 15. I mean x 15, y equal to 5. Now this intersection is the intersection of these two equations. I'm used the calculator for that. 8, 160, 4, 12, 180. Right, 8, 160, 4, keep doing that, 4, 12, and 180. Right, we have 7.5 and 12.5. This point is 7.5 and 12.5, and of course in all the intersection we have here's 0 and 15, 0, 0, and here's 15, 0 and 15, 5. So all of the solution are the region connected by those points. Right, so I'll just graph each inequality, find the intersection, and at the end it's maybe easier to see that a little bit. The shape of the region. Right. Let's go to this example. Suppose a manufacturer makes two types of ski, trick ski and slalom ski, and each ski requires 8 hours of design work and 5 hours of finishing work. Each slalom ski requires 6 hours of design and 10 hours of finishing. The total number of hours allocated for design work is 160 and for finishing work is 180. I just want to change this so the number will come out a little bit easier to calculate. Right. So as always, when we read the problem, we look at the end and we see how many trick ski and how many slalom ski. So in that case, that's what we ask for, how many of each. And the way we set it up on the table to summarize data, each of this will correspond to a column. So we will have two, one for X, one for X, the trick ski, and one for Y, slalom ski. And then for each type, there will be design work and the finishing work. Right. Now for the trick ski, require 8 hours of design and 5 hours finishing. For slalom ski, require 8 hours design and 10 hours finishing. Total, we have 160 hours to design work for design work and 180 for finishing work. Right. Now, remember, I think we touched on this earlier. We have 160 hours to dedicate for design work. We might not need to use all of them. So in that case, we don't write AX plus AY equal to 160. We can use less than 160 hours if we choose to, but we cannot choose more than that. Same thing here. We don't have to use all 180 of them. So it has to be less than or equal to. It cannot be more than 180. And just like any problem with application business, the quantities cannot be negative. So usually we're going to have that in. I shall have this. We translate the work problem into a math problem now. Right, we'll just graph one by one. Right, and let's look at the first graph, AX plus AY. Less than or equal to 160. I'm going to graph this first. Let's look at the table. This is exactly like the previous problem. When x equal to 0, we don't have x. AY is 160, so x equal to 0, y equal to 160 divided by 8, that's 20. And now AY, y equal to 0, AX equal to, AX equal to 160, so x is equal to 160 divided by 8, so that's 20. So that, again, we're not going to graph it yet. We need to have all the points so we know how to what number required on the axis. Just going to leave like this. If we want to, we can do the test point at this point. 0, 0 here will work just fine because it's not on the line. But again, I good advice. It would be wise to graph a line first to see what point do we test. I think we can test later. That would be a wiser decision. So 5x plus 10y equal to 180. When x equal to 0, that's 0, 10y equal to 180. Divide by 10 on both sides, we have 18. Now, when y equal to 0, 5x equal to 180. Divide by 5 on both sides, 180. $36. Right. And then we can choose the test point. Like I said, it will be wiser if we draw a line first, so we know which point do we test. Right. Now we look at all the points here. The x values go from 0, the highest 36. The y values is the highest 20. So we should choose something that we have all of those points. And the axis here, we have 10 ticks horizontally and vertically. So I choose 4 each. So we can go up to 40. And that look all right there. So again, so for a 12, 16, so that 20 and 24, 28, 32, 36, and 40. 1, 2, 3, 4, that 20. 1, 2, 3, 4, 5, that 40. We have that axis. Now the first one is all of them have the equal sign, so it's going to be a straight line, not a dashed line. 20, 20. Again, we have x and y greater than or equal to 0, so we don't have we have everything in the upper right hand corner here. And then 0, 18, that's 16 to 18 is right, about half of that. And then 36 is here. Right, so that 18 and 36. Right. Now test point. We do know 0, 0 is not in either of the lines, so we can test 0, 0 easily. 8, put 0 in for x, 0 for y. Is that less than 160? So 0 less than 160 equal to 160, so that's good. Check. Now the test point for 0, 0. 5 times 0 plus 10 times 0 less than or equal to 180. That's 0, that's 0. So if 0 less than or equal to 180. And that check. Yeah. So that means 0 belongs to the region with respect to this inequality. Now look at this. So this is going to be below the line, below the blue line. And it's also below 0, 0 here, also part of the solution, so we will set the region below. Right. And now we have the intersection. Obviously it's going to be this. So we have the origin 0, 0. This is 18. 0 and 18. That's 0 and 20. In 20 and 0, x equal to 20, y equal to 0. 20 and 0. Now we just need the intersection. So the intersection of these two equations so second matrix for the 16. So 4 and 16, that look reasonably correct. So the solution will have the region of 5 points here with 1, 2, 3 and 4. So 1, 2, 3 and 4, those 4 points. So we have that. Right. So with that, we finish section 5.2 in Math 1324. As always, thank you for watching and see you in another video in Math 1324.